You can safely apply the Copernican principle to most questions, which means the things we know and experience are not unusual. So if we have rocky planets in the Milky Way, then Andromeda will. Right. But having said that, so somebody pointed this out, but we haven't found too many when we look for exoplanets, partly because maybe a lot because the techniques associated with finding exoplanets are biased towards finding hotter and bigger planets like Jupiter's and Neptune size or whatnot planets. But what we have found so far are more planets that kind of resemble Jupiter's and Neptune's. But the interesting thing is that we find them at distances that are closer to their host star. So what we have found when we have gone to look for exoplanets, so I kind of gave you the observational answer. So sort of the theoretical answer might be yes, of course, we have rocky planets here in the Milky Way, in our own galaxy. So why not in other galaxies too? So that's kind of a philosophical answer, right? The philosophical answer is, oh, we philosophize that we are not special. So there are rocky planets in other galaxies as well. That is one answer. The other answer is the observational answer. What have we observed so far? Have we seen a lot of Earth-like planets? And the answer is no. What we see is more of the hot Jupiters and hot Neptune type of planets when we observe. Now, that could be because of our observational techniques being biased towards those planets. It could very well be, but that's the observational answer, okay? She don't care about you or your suggestions. You won't feel anything. Is that like, I don't know what that means. Space-time is warped by a rotating black hole, closed time-like curve. Potential for back. Oh! Space-time is warped by a rotating black hole. When did we talk about rotating black holes? We did. Space-time is warped by a rotating black hole, closed time-like curve. Closed time-like curve. Potential for backward time travel. Do you believe? Sure. If it's possible physically, a rotating black hole, closed time-like curve. This is all coming back to me. We did talk about this at one point. Potential for backward time travel. Sure, sure. Actually, we know that time travel is basically possible microscopically. So if it's possible microscopically, actually, I'm willing to believe that time travel is extremely possible. I mean, it is possible for particles, for microscopic level stuff. But macroscopically, can we experience time travel and go backwards in time? I'm not so sure. I would maybe say no. Anything else? We kind of talked about let's see. We kind of talked about the ripping of space-time. I love that there is so much active participation by people.